Hi ladies and gentlemen, so today we're taking a look at 3.3 long division. This is technically 3.3 part A, and we also have a 3.3 part B, both of which are dealing with dividing. They're just two different methods. Alright, so let's get started. So reviewing some long division from back in elementary school, I want you to give it a try to divide 457 and 7 using long division. Alright, so starting off, and if you had to turn to Google to remember how to use long division, that's okay. It's been a really long time since we've done this. So our dividend is the first number, 457. So that is the number that's going to go underneath our division sign here. Our divisor is that number that we're dividing into the 457, which is 7. So this is how we're going to set it up. Then from there, we have to think, okay, well 7 does not go into 4 because 4 is too small. So we have to think, how many times does 7 go into 45 fully and not get going over 45? So we have to think, okay, 7 times what number gets us really close to 45 but not going over 45? And that would be 7 times 6, because the product of 7 and 6 is 42. Now, subtracting 42 from 45, we're left with 3. Then we carry down the next number, and we get 37. So now we have to think 7 goes into 37 how many times? That would be 5, because 5 times 7 is 35. And subtracting those, and we get a remainder of 2. So when we're writing our final answer, we would get 65. Our remainder is 2, but writing that in fraction form, it would be 2 over 7, or 2/7. So 457 divided by 7 is 65 and 2/7. We're going to be going through this exact same process with polynomials next. So using long division to divide polynomials is our only objective for this lesson. To kind of show you how it's going to look, if I have x plus 2 as my divisor and it's dividing into 2x squared plus 7x plus 7, I'm going to continue that same process of thinking about, okay, so this first number in my divisor, x, goes into 2x squared how many times? In other words, we have to think x times what number is going to get us 2x squared. Right? So x times what number is going to get us 2x squared? That's where they got this 2x at top from. Once they figure out the answer to that question, they take that value in their quotient, this 2x, and they multiply it in to this binomial that's in the divisor, and that is where they get 2x squared plus 4x from. Now that they get there, they take this entire quantity and it is subtracted from the quantity above it. So 2x squared minus 2x squared is 0, so that cancels out. 7x minus 4x is 3x, and then the plus 7, we don't have anything to subtract from it, so it carries down. Now we have 3x plus 7. Right here. This is where we're at. So now going back to the drawing board, we think, well, x, at the first piece in our divisor, times what number? So again, we're thinking x times what number is going to give us this first term here of 3x. So x times what is going to give us 3x? And the answer to that question is 3, so that's why we have a plus 3 in our quotient. From there, we take that positive 3 or that plus 3 and we multiply it into each of those pieces of the divisor. 3 times x gives us that 3x. 3 times 2 gives us plus 6. Then from there, we go through the subtraction process. 3x minus 3x cancels out as just 0. 7 minus 6 is 1, so we end up with this remainder then. So the way that this answer is going to look is 2x plus 3 from our quotient plus our remainder, which is 1, over our divisor, which is x plus 2. So, this process is kind of lengthy, okay, but it is very repetitive. It's the same cycle over and over and over again until you get to your remainder. So, hopefully after a couple of example problems, you can begin to feel like you understand this method. But keep in mind, if you begin to understand this method but you just don't like it, there is another method that we're going to show you with lesson 3.3b with synthetic division. But first, let's learn all about long division and go through some example problems.